Good morning, class.
Good morning, sir.
Good morning, sir.
Good morning. I think we are done with regression. Oh, sorry, correlation, right? We have done both Spearman rank and Pearson correlation.
Yes, sir.
Okay. All right. So let me ask you guys one question. Then we'll move to the next topic. So Devanshi, maybe you can answer it. So
Yes, sir.
in the example of correlation, we were talking about say height and weight. Okay, so we try to find out whether height and weight they are correlated or not. Okay, and through the example we established, yes, there is a very strong correlation between these two variables. So once you established that there is a strong correlation between height and weight, so what do you think should be the next question I should ask from the data?
Sir, question.
हाँ, आपने डेटा कलेक्ट किया है कि हाइट और वेट में रिलेशनशिप है कि नहीं है, एंड दैट यू फाउंड आउट थ्रू कोरिलेशन, यस देयर इज अ रिलेशनशिप. सो अब ये एस्टेब्लिश होने के बाद आपको क्या लगता है, व्हाट शुड बी माय नेक्स्ट क्वेश्चन फ्रॉम द डेटा?
Sir, I don't know.
ओके, मनस्विनी.
So, according to me, I think the next question should be, is the correlation positive or negative?
नहीं, वो तो हमें पता लग गया इन कोरिलेशन कि कोरिलेशन का डायरेक्शन क्या है और कोरिलेशन का स्ट्रेंथ क्या है,
Oh,
कि
okay.
कोरिलेशन इज वेरी स्ट्रांग और नॉट, कोरिलेशन इज पॉजिटिव और नेगेटिव.
Okay.
ठीक है,
So, I'm not sure.
just I mean try to imagine कि अब ये डेटा पे जब when we established there is a correlation, so अगला क्वेश्चन क्या पूछ सकते हैं हम? डिमिट्रियस.
Sir, I'm guessing, but like the example you talked about the ice cream and summer and swimming. So do we have to check whether the correlation makes sense or not?
That we always do before we start calculating this correlation coefficient, whether the two variable, the correlation between two variable makes any sense or not. ठीक है ना? So I told you there should be some logic before you start calculating this correlation coefficient. So we know that there is some link, there may be some link, okay, between two variables. That is why we went ahead and calculated this correlation coefficient. We established there is a correlation. Now what next? Nihal?
Sir, Nehal.
Nehal, sorry. Nehal.
Yes, sir.
हाँ बच्चे बताओ आप, what do you think should be the next question?
Sir, I'm not sure.
You're not sure. Okay. Shivani.
Sir, I'm also not sure about what will be the next.
अच्छा. Okay. चलो ठीक है, चलो मैं बताता हूँ आपको. So once I know that height and weight are correlated, so what I think is the next question should be, if they are correlated, what I mean, if I change something in height, weight में कितना change होगा? So if I increase the height by 1 centimeter, weight कितना kilogram increase होगा if it is a positive correlation? Don't you think that should be the next question we should ask? So once it is established, height and weight are correlated, then we want to quantify कि अगर if I change my independent variable by 1 unit, how much change in the how many units change I will see in the dependent variable. तो अगर मैं हाइट को मेजर करता हूं इन इंचेस, तो अगर 1 इंच हाइट इंक्रीज करेगा तो वेट कितना किलोग्राम चेंज होगा, राइट? So that question I can answer using another technique which is called as regression. So today we are going to talk about regression. So let me share the slides with you guys first. I will give you an introduction to regression. And then I will show you a video and then we'll do one example. Okay. All right. So कौन बताएगा मुझे what is the meaning of regression? Anyone in the class who can tell me what is regression? Regression is an it is English term, right? You all must have used this term somewhere during your class 11 or 12. Otherwise also it is an English term, so you all know what is regression. Adhish. Adhish. Adhish is not around, not in the class. अरे भी रिग्रेशन का मीनिंग तो सबको पता होना चाहिए ना. No answer. Am I audible to you guys?
Yes, sir.
Yes, sir.
तो yes, Nehal बताओ. Nehal.
Sir, regression means to predict the variability or the relationship between the equation.
nahi, that's not the literal meaning of regression. Yes, Demetrius.
Sir, is it going back to a previous less developed stage?
Yes, that's what regression is. I am sure of all of you have heard about the word progression. Progress. Progress तो सबको पता है ना? Progress क्या होता है?
Yes, sir.
Yes,
So
sir.
progress से ही आया आपका progression. So progression का antonym is regression. Okay. So antonym of progression is regression. Regression meaning going backwards. Progression moving forward. So how this regression we are going to use in statistics. So one guy, he was studying the height. So he collected data on height of parents and height of their kids. And through that data, he found out that height of kids from taller parents. So you have parents who are of average height, parents of taller heights, parent of height less than average. So he collected all those heights and he collected the height of their kids also. And what this guy observed that height of kids born out of taller parents try to go towards average height of the population. So जो parents tall हैं उनके बच्चों का height है, so we expect कि वो बच्चे भी tall होंगे, right? But the height of these kids tend to go towards average height. That means it is going backward towards the average. So that is why he gave this term regression. Okay, and what we do through regression, we try to predict. So हमने establish क्या relationship, that there is a relationship between two variables. Now we try to predict if there is a relationship. So एक का change होने से कितना change होता है दूसरा variable. Co-variable से हमने क्या check किया था, whether the two variables are moving together or not. Okay, and once that is established, if they are moving together, so अगर एक value mean से इतना distance पे तो दूसरा value mean से कितना distance पे आना चाहिए. So that we find out through regression. All right. So it was first used by this guy Francis Galton, who had done this experiment on height of the kids. Okay. And what we do in regression, we basically try to establish the relationship. Okay, the strength of the relationship. And this regression is basically of two types. One is called a simple regression and one is called as multiple regression. Like in correlation, we had one dependent variable, one independent variable. Similarly, the regression also, we have dependent and independent variable. So the independent variable is called as exploratory variable, and dependent variable is variable that we try to explain. For example, height and weight. Okay, so if you try to predict the weight of a person using the height data, so then height is exploratory variable and weight is the variable that you are trying to explain. And since this regression is of two types, so what are these two types? One is simple, one is multiple. So what is simple, what is multiple? So when you have only one exploratory variable and one variable that is being explained, so only two variables you are working with, one is dependent, one is independent. So that is called as simple regression. We know that weight is not only dependent on your height. There are certain other factors also that play a role in deciding what your height will be. So that may be your family history, that may be your physical activity, that may be your diet, that may be many other factors. So if you try to include more than one independent variables, so always remember, it doesn't matter whether you are working with 2 variables or 20 variables. Dependent variable is always one. So you try to explain weight based on different independent variables. Okay, so if you are using variables, more than one independent variable, that is called as multiple regression. Okay, and you try to make one equation. So that equation is called as linear regression equation. So that is a straight line relationship, which is given by y equals mx plus b. So what is this y equals mx plus b? So yes, so this is the equation. So y is your variable that you are trying to predict, basically your dependent variable. X is your independent variable or your exploratory variable. M is your slope of the line, and B is your y-intercept. So B is basically, you see this thick line, okay, this thick line where it is touching the y-intercept. So distance of that point from 0 coordinate. So that is called as y-intercept, and slope is basically difference in y divided by difference in x. Okay, so you basically have to find out these two values. What is the slope of your equation and what is the y-intercept of your equation. So once you have these two numbers with you, for any given value of x, you can calculate the value of y. Okay, I think I should not go to this equation. So now let us first try to understand some basics behind this regression. So I am going to show you a video that will talk very basic about this simple linear regression. So we will go through this video first and then I will explain more. So let me start this video. Okay, I hope the screen is visible to you all.
Yes, sir.
Okay. And you guys can, so are you getting the audio also?
Yes, sir.
Okay,
Yes, sir.
very good.
Yes, sir.
Right.
Hello. Thanks for watching, and welcome to the next video in my series on basic statistics. Now, as usual, a few things before we get started. Number one, if you're watching this video because you are struggling in a class right now, I want you to stay positive and keep your head up. If you're watching this, it means you've accomplished quite a bit already. You're very smart and talented, but you may have just hit a temporary rough patch. Now, I know with the right amount of hard work, practice, and patience, you can work through it. I have faith in you. Many other people around you have faith in you. So should you. Number two, please feel free to follow me here on YouTube, on Twitter, on Google+, or on LinkedIn. That way, when I upload a new video, you know about it. And it's always nice to connect with my viewers online. I feel that life is much too short and the world is much too large for us to miss the chance to connect when we can. Number three, if you liked the video, please give it a thumbs up. Share it with classmates or colleagues or put it on a playlist. That does encourage me to keep making them for you. On the flip side, if you think there's something I can do better, please leave a constructive comment below the video, and I will take those ideas into account when I make new ones. And finally, just keep in mind that these videos are meant for individuals who are relatively new to stats. So I'm just going over basic concepts, and I will be doing so in a slow, deliberate manner. Not only do I want you to know what is going on, but also why and how to apply it. So all that being said, let's go ahead and get started. Okay, so this is the first video in what will be, or is, depending on when you're watching this, a multi-part video series about simple linear regression. In the next few minutes, we will cover the basics of simple linear regression starting at square one. And for the record, from now on, if I say just regression, I am referring to simple linear regression as opposed to multiple regression or models that are not linear, which we will hopefully get to those at a later date. Now, regression allows us to model mathematically the relationship between two or more variables, using very simple algebra to be specific. For now, we'll be working with just two variables, an independent variable and a dependent variable. The truth is, when we talk about how, quote, good a regression model is, we are actually comparing it to another specific model. Oftentimes, students don't realize this. So in this video, we're going to talk about that idea. I will also begin introducing basic terminology and concepts that will carry you through your work using regression. There are no formulas or calculations in this video. We're just introducing the underlying meaning behind good regression models. So if you are new to regression or are still trying to figure out exactly what it even is, this video is for you. So sit back, relax, and let's go ahead and get to work. So as always, I like starting out my videos with a problem, and a relatively real-world problem at that. So we'll call this one Tips for Service. So let's assume that you are a small restaurant owner or a very business-minded server or waiter in a nice restaurant. Here in the US, tips are a very important part of a waiter's pay. Most of the time, the dollar amount of the tip is related to the dollar amount of the total bill. So if the bill is $5, that will have a smaller tip than a bill that is $50. Now, as the waiter or the owner, you would like to develop a model that will allow you to make a prediction about what amount of tip to expect for any given bill amount. So therefore, one evening, you collect data for 6 meals. So a random sample of 6 meals. But unfortunately, when you begin to look at your data, you kind of forgot something. You realize you only collected data for the tip amount and not the meal amount that goes with it. So unfortunately right now, this is the best data you have. So you have a random sample of 6 meals and the tip amount for each one of those meals. So $5, $17, $11, and so on. Now here's the question. How might you predict the tip amount for future meals using only this data? There's only one variable here, the tip amount. The meal number is just a descriptor. So we have one variable, the tip amount. But I still want to challenge you to come up with a model that will allow you to predict within some, reason what the next tip is going to be. How can you do that?
Hello, welcome to the postgraduate program in Artificial Intelligence and Machine Learning offered by the University of Texas at Austin in collaboration with Great Learning.
Think about it. So the first thing we're going to do is we're going to visualize our data. As you know, if you watch my other videos, I am a huge advocate of visualizing our problems, making charts, graphs, diagrams, whatever we have to do to make them visual. So the first thing we'll do is we'll make a graph of our tips. Now on the x-axis on the bottom, we have our meal number. Now that's not a variable. That's just a descriptor of what meal we're graphing. Now on the y-axis or the vertical axis, that's where we will graph our tip amount. Let's go ahead and see what this looks like. So for meal 1, we had a tip of $5. So we'll go ahead and graph that at around $5. For meal 2, we had a tip of $17, so that goes way up there. For meal 3, we had a tip of $11, so that goes there. Meal 4, we had a tip of $8, that goes there. Meal 5, it was $14 tip, and meal number 6, it was a $5 tip. So here are our data points. Remember, we're only dealing with one variable, that's the tip amount, and the meals along the bottom just describe where we're graphing each point. And the order does not matter. We could have graphed these in any order. This just happens to be the one we ended up with. Now, what's really the most you can figure out about this data? How would you predict what the tip for meal number 7 would be? Is it going to be like meal number 6, that's $5? Is it going to be like meal number 2, which is $17? How would you come up with the best guess or estimate for the next meal using only one variable? Well, you would use its mean. So the mean for all 6 tips is $10. So guess what? That's the best we can do. With only one variable, the best estimate or the best prediction for any given meal tip is $10. So we'll go ahead and put a line at $10. So that, for this model, that is our best fit line. That's all we have. One variable, tip amount. The mean is the best predictor of any given tip amount. Now, obviously, if you look at this chart, our tips do not fall on the $10 line. They're scattered around it. But still, it's the mean. So that's our best estimate for what the next tip or any given tip would be. So here's our graph again with our tips, our mean, and our tip amount. Now I just want to stress that the tip amount is y bar, so that's the mean of y, and that's for 2 reasons. One, the dependent variable, which it will be as we progress forward, is always the y of the x and y axes. And of course, we're graphing it on the y-axis, so it should be y bar. So here is the basic concept that I really want you to remember in your head as you go forward. Now, obviously, simple linear regression is about 2 variables, but we're starting off here because this is where it all begins. With only one variable and no other information, the best prediction for the next measurement is the mean of the sample itself. So the variability in the tip amounts, because they're not on the line, they're above and below, the variability in the tip amounts can only be explained by the tips themselves, because that's all we have. So the way they're above and below the line, that's just the natural variation in the tips. But the basic point is this: with only one variable, the best way, the only way we can make a prediction about the next tip amount in this case is the mean. So our best prediction for the tip of meal number 7 is $10. So let's talk about the goodness of fit for this line and our tips. Now, obviously, we know that the data points, the actual observed values, do not fall on that line. They do not fall on the $10 line. Some are above and some are below it. So that tells us how good this line fits these observed data points. Now, one way we can do that is to measure the distance they are from that best fit line. Now, we did this to some degree when we were talking about standard deviation. Remember, we're talking about the distance each data point is from the mean. Well, guess what we're doing here? The distance that each data point is from the mean, because the mean is our line of $10 here. So for meal number 1, our tip was $5. So that's $5 below our mean of $10. So that's -5. Meal number 2 had a tip of $17. That was $7 above our mean. Meal 3 was $11. It's $1 above our mean. Meal 4 was $8. That's 2 below our mean. Meal 5 was $14. That's 4 above our mean. And meal 6 is $5. That's 5 below our mean. So these are the distances, in this case dollar amounts, by which each observed value is different from or deviates from the mean of $10. Now we have a name for these. They're called residuals. So the distance between the best fit line, which in this case, because it's one variable, is $10, the distance from the best fit line to the observed values are called residuals. Now they're also called the error. So the distance is also called the error because that's how far off the observed value is from the best fit line. Now you notice a few more things here. If you add up the residuals on the top, just above the line, 7 plus 1 plus 4, that's 12. Add up the residuals below the line, 5, 2, and 5, well, that's -12. So the residuals always add up to 0. And that's another important concept to keep in mind as we go forward.
Number 2 on the 50 best jobs in America for 2021 list. Data science roles are game-changing.
Now, if you remember in standard deviation, one of the steps was that we took the deviations from the mean and we squared them. Well, guess what? We're going to do the exact same thing here. So the residual for meal 1 was $5, so it's $5 below. So we square that and it squares to 25. Meal number 2, it was $7 above. We square 7, it's 49. So on and so forth. So in the right-hand column of our table, we have our squared residuals. Now the question is, why do we square them? Well, we square them for the same reasons we square the deviations when calculating the standard deviation. Number 1, it makes them all positive. So if we square a negative number, it obviously makes it positive. And number 2, it emphasizes the larger deviations. So a deviation of 2 will square to 4, but a deviation of 5 will square to 25. So the squaring really exaggerates the points that are further away. Now what we can do is we can take these residuals, these squared residuals in the right-hand column, and we can add them up. And they're called the sum of squared residuals, or the sum of squared errors, or the SSE. Now, where have you heard that before? Well, you've heard it everywhere in statistics. You've obviously heard it in standard deviations. You've heard it in ANOVA. Same idea. Sum of the squared errors. It's a fancy way of saying we add up the squared residuals. And when we do so, it's 120. Now, when we say squaring the residuals, we literally mean squaring them. So 25 over here on the left-hand side, that's -5 squared. 49 is 7 squared, and so forth. But we actually mean squares. So when we square each residual or error, we're actually making squares. So when we say sum of squares, we literally mean the sum of squares. So 49 plus 25 plus 1 plus 4 plus 16 plus 25 adds up to 120. Now, here is sort of the blockbuster bombshell concept of this video. The goal of simple linear regression is to create a linear model that minimizes the sum of squares of the residuals, same thing as the sum of squares of the error. So what we're going to do is we're going to create a different line through the data once we introduce an independent variable that will minimize the size of these squares. And actually, mathematically, we'll come up with the line through the data that minimizes these squares as much as they can be. And that'll be our best fit line for the data. But again, in this problem, we're only using one variable. We're only using the dependent variable. So when we introduce the independent variable, it will sort of take away for its own self some of this error we see here. If our regression model is significant, it will eat up some of the raw error we had when we assumed, like in this problem, that the independent variable did not even exist. So what we're doing here in this problem, we're taking a simple linear regression problem that in theory has an independent variable called the bill amount and a dependent variable called the tip amount. But what we're doing is pretending that the bill amount doesn't even exist. We're only using the tip amount. So that creates a sum squares residuals of 120. Now, when we introduce the independent variable of bill amount, what will happen is that will create a different best fit line through our data. And what it will do is it will sort of eat up some of this. So when we do regression, we're going to have sum of squares regression and sum of squares error. So by introducing that independent variable of bill amount, it will create a new line that goes through the data. That new line will explain some of this sum of squares, and therefore it will reduce the SSE down, the sum of these squares, as much as it can be. So the regression line will and should literally fit the data better. It will minimize the residuals. So when conducting simple linear regression with two variables, we will determine how good that line fits the data by comparing it to this type, where we pretend the second variable does not even exist. So when we say a model is good, a linear regression model is good, what we're saying is that it reduces the sum squares of the error by a large amount, which is another way of saying we're comparing the other best fit line to this one you're looking at right here. Simple linear regression is always a comparison to what we would have if we only had the dependent variable. So if a two-variable regression model looks like this example, what does the other independent variable do to help us explain the dependent variable? Well, it does nothing. If we introduce bill amount into a two-variable simple linear regression, but the best fit line looks exactly like this, then the bill amount didn't give us anything. It didn't explain the variability in the tip amount any more than the tip amount itself did. So we're always comparing our simple linear regression best fit line to this one. Basically, the mean of the dependent variable alone. Okay, so a quick review. So simple linear regression is really a comparison of two models. The first one is where the independent variable does not even exist, and we just use the mean of the dependent variable like we did in this video. And the other use uses the best fit regression line, where we go ahead and introduce that second variable, the independent variable, in this case, the meal amount, and that creates a different line, and then we compare that to the first one. Now, if there is only one variable, like in this example for this video, the best prediction for other values is the mean of that dependent variable. And this was $10. Now, the difference between the best fit line and the observed value is called the residual, or the error. The residuals are squared and then added together to generate a sum of squares, literally, residuals or error, so SSE. So we square the residuals and add them together, sum of squares residuals, or most often it's called sum of squares error. So simple linear regression is designed to find the best fitting line through the data that minimizes the SSE, that minimizes the area of the sum of squares residuals, that minimizes the area of the sum of squares error. And actually through calculus, it is the best fitting line. Now, I'm not going to go into the calculus behind that, but you're just going to have to start trusting me on faith that when we come up with a best fit line in simple linear regression, that literally is the best fit line that reduces the SSE. Okay, so that wraps up our very first video of many on simple linear regression. So I just want you to realize in this video that later when we talk about the best fit line in regression, we're actually comparing it to the situation where we don't have the independent variable at all. We're just comparing it to the case where we're looking at the mean of the dependent variable. So in this case, in this video, all we had was the mean of the tips, $10. That's all we had to go on. So therefore, our best guess or best prediction for the next tip was $10. Now later, when we introduce the meal amount, what will happen is we'll get a different best fit line that will explain or take up some of that error regression. It'll reduce the error, we'll have a different line, and we'll have smaller, hopefully, residuals. If the regression line is flat across, like we saw in the first example of this one, then the regression doesn't tell us anything. The meal amount doesn't mean anything. So the best guess is really just the mean of the tips. So we'll go more into this example in the second video, but I just wanted to lay the foundations for that. Look forward to seeing you next time.
All right, guys. I hope you could understand few things from this video. So any questions, any doubts from this video? If any point is not clear.
Sir?
Yes, Manaswini.
Sir, so what exactly is the difference between the best fit line and the best fit regression line?
Best fit line and best fit regression, both are same.
Oh, they're the same.
Chalo, let me. Yes, they are the same. So that's what he was trying to explain in this video. So he was taking the example of like the bill you pay for your meal and the tip you pay for that same meal, right? So I can explain this using another example. Like I can take the example of say height and weight. Okay, so let me share this. Okay. So I can explain the same concept using another example. So let us assume there are say 20 students in your class. Okay. So let me ask you guys one question. So let us assume you guys are 20 students in a class. Okay. And you found out that there is a new student coming in the class. Okay. A new student has taken the admission in the class. You have no idea who the student is, whether the student is a male or female, nothing. You just came to know one new student has taken admission in the class. Now you want to guess, okay, what is the height of this new student. ठीक है. So ये क्लास में आपको एक टास्क दिया गया, चलो गेस करो ये नया स्टूडेंट का हाइट कितना होगा. So what do you think should be your best guess? क्या नंबर दोगे आपके भाई नया स्टूडेंट का हाइट तो इतना सेंटीमीटर होना चाहिए. So any idea what should be the best guess? Yes, Namrita.
Sir, 170 centimeter.
How much? 100?
170 centimeter.
170 centimeters. Very good. अच्छा प्लीज ये भी बताओ ये मैजिक नंबर कहाँ से आया? 170 सेंटीमीटर्स. या आपने ऐसे ही एक वाइल्ड गेस किया है ये? आयुषी. आयुषी.
Yes, sir.
हाँ बच्चे आप बताओ आपको क्या लगता है अगर कोई नया स्टूडेंट एडमिशन लेगा आपका क्लास में तो उसका हाइट कितना होना चाहिए? साहिबा आप बताओ बच्चे.
Yes, sir, where you calling? I couldn't unmute.
अच्छा बताओ what should be the height of this new
The
student?
average.
Average height. Okay. Yes.
You could say somewhere between 5'7" to 5'10".
नहीं I'm asking about one number. You have to give me one number. कि नया student का height is this much. You have to give any one number and you have to explain why you chose that number.
I would go for 5'7".
And why 5'7"?
Because, sir, as in general, for it would be considered the average height for Indians.
Okay. All right.
And
ठीक है.
if it's a girl, I would go with 5'5", or if it's a boy, I would go with 5'7".
Okay. ठीक है. Yes, correct. So see, you don't know whether this person is a male or a female. You have no idea about this person. So if you have to guess what is the height, then you have to calculate the average height of your class. Okay, and then you can say that I guess the height of this new student is this much. So if your class ka average height is 170, then you say 170 centimeters. You may be right, you may not be right. ठीक है ना? When the new student comes and if you measure the height, so there are both the possibilities. वो student का height 170 है या वो student का height 170 नहीं है. अगर 170 है योर एरर इज 0. सो आपने जो प्रिडिक्ट किया था एक्चुअल में उतना ही निकला. और अगर 170 नहीं है देन वो जितना भी हाइट है नया स्टूडेंट का, सो दैट इज योर एरर मार्जिन. सो ये तो एक स्टूडेंट का स्टोरी हो गया. सपोज देयर आर 5 स्टूडेंट्स हु आर टेकिंग एडमिशन और आपको पांचों के लिए गेस करना है. सो आपका तो पांचों के लिए गेस 170 सेंटीमीटर होगा, but it is quite possible that all of these students are not with height 170 centimeters, right? So if that is the case, you'll be having error. So as you keep on guessing based on just only this average, आपका error margin will keep on increasing. ठीक है? So you have to find out a way to minimize this error. If you can minimize this error, your prediction will be better. Okay, so to minimize that error, we go for that equation, which is regression equation. And what happens in that regression equation? So we try to find out this sum of square, SSE. Okay, so sum of square of all the residuals or all the errors. So we'll talk more on this in the next class. Okay, I guess next class we have on Friday. And Thursday we'll try to have one extra class. If that happens, I will take that class. Okay, so that's all for today. I would suggest you go and read about this regression and we'll discuss more. So that's all for today. Thank you very much, guys. Bye bye. Have a nice day ahead.
Thank you, sir.